Okay, in this video we want to find the domain of two functions. We've done something like this, similar to this before, involving different types of functions. Here we're dealing with two log functions. But you can never have enough of these types of problems. Knowing how to find the domain of a particular function is very important in mathematics. So let's look at the first one here. I'm going to find the domain. Now first, let's point out, and again, if you want to pause the video and try it yourself. So these are the only two problems in the video here. So first of all, for the first one, it has a square root in the log. Now if it was just a plain old log, say the log of x. Base here is understood to be 10. For this one, it's understood to be e. In both cases, the base would be larger than 1. So you would expect a graph to go something like this. If the base is larger than 1, it would go something like this. It will pass through this point right here because the log of 1 to any base is 0. So it crosses the x-axis right here. Now generally, when you're talking about log of something, this has to be positive. The log of a negative is not defined. But in this case, you don't want to say that the domain is just x greater than 0, because notice if x is greater than 0, it's going to be negative. Between 0 and 1, the graph falls below the x-axis, so it's negative. This would be negative in here. So when we talk about domain, we're talking about real numbers. So this would not be defined if x is slightly between 0 and 1. Now we notice in the graph, if it's larger than 1, then it's above the x-axis. Then this log s, natural log of x, would be positive and you're okay. So in this case, the domain would equal to the set of all x, such that x is greater than or equal to 1. And let me put it this way here. In set builder notation, it would be written actually like this: set of all x such that x is greater than or equal to 1. That would be your domain. Now if there's no square root, then all you want is that x is not negative or 0. So you would just say x greater than 0. But because of the square root, we don't want a negative quantity under the radical. So we write the domain this way, or in interval notation, brackets, meaning we're including 1, and then all the way to infinity. And we have this. So that would be two ways to write the domain of the first one. Again, if it doesn't have the square root, it's just a set of all x such that x is greater than 0. Now let's look at the next one. Now this one, we don't have a square root. It's just if you just look at the quantity in the parentheses, it's just a rational expression. But still we want this. This has to be positive though. This has to be positive. So we want, basically you just want to solve this rational expression. X plus 1 over x. We want this quantity to be greater than 0. The log of 0 is not defined. The log of a negative is not defined. It doesn't matter what the base is here. In this case, it's base 5. So then you solve this just like you would solve any rational inequality. I've done something like this before. But the best way to solve it is just on the number line. Plot the numbers and make the numerator and the denominator 0. So the numerator is 0, you can see at negative 1. The denominator is 0 at 0. This divides and infinity is over here on the right. Negative infinity on the left over here. And then we just examine the sign of this expression for numbers from 0 to infinity, from -1 to 0, and from negative infinity to -1. Just pick any number larger than 0. Say 1. Put a 1 where the x is. 1 and 1 is positive. 1 where the x is positive. Positive over positive is a positive. Between -1 and 0, we're going to pick a -1/2. So I put a -1/2 where the excess in the numerator. That quantity is going to be positive. And then a -1/2 in the denominator will be negative. Positive over negative will be a negative. And then to the left of -1, we'll pick -2. So -2 where the x is in the numerator will give me a negative, -2 and 1. And then -2 where the x is in the denominator is negative. Negative over negative is a positive. So this tells you the sign. If you were graphing this, this would tell you where the graph is. So positive means it's above the x-axis. A negative means it's below the x-axis. Here, we're just concerned about the sign, because we want this quantity here to be positive. So it's positive where? In that interval? In that interval. So from that, then you can say the domain. First, write it in set period notation. It's a set of all x, such that, okay, positive, we're looking for positive, so to the left of -1. So this will be such that x is less than -1. Okay, we don't want 0 in the numerator or 0 in the denominator, so that's why we don't have any equals here. Or x can be greater than 0. With those restrictions, this expression will always be non-negative, and the log will exist. Now, in interval notation, we would write it this way: negative infinity to -1, union (0 to infinity). This is also the domain. The first one is in set builder notation. The second one is in interval notation. Thanks for watching. We'll see you next time.